In this lesson out of Classroom Mathematics, we are starting with chapter 15 on area and perimeter, and we're going to look at the formula for perimeter. So to define perimeter, the perimeter of any closed two-dimensional shape is the total distance around the outside of the shape. So in other words, if we look at the shape below, then imagine it's the top view for a building or a path that you want to walk. Then it's calculating the total distance if you walk around the building, the distance that you would go all around, or if you want to walk through a path, you just calculate how far would you walk if you walked this path. So for an overview on this video, we're going to look at the formula for perimeter. Then we're going to just look at a few notes, and then finally we're going to do a few examples. So first of all, when we have a square, if we want to calculate the perimeter of a square, you can see that the square sides are all equal, so we have to go around the square, and that means we just have to add the side 4 times, or we can just simply say 4 times the side's length. For a quick example on that, if I have the perimeter of the following square, I can say that the perimeter is equal to 4 times the side, and that's going to be equal to 4 times 25, and that is just simply equal to 100 meters. Then for a rectangle, now in a rectangle we have a length and the width or breadth. So in other words, we have to go around the shape. We're going to say this length times or plus this breadth times plus this length plus this breadth. So the formula would look as follows. And if we want to simplify the formula, we can add the like terms. So we can say length times length is 2L, and same with the breadth, then the formula looks as follows. And if we want to simplify it even further, we can factor out the 2, and then the formula looks like that. But I usually just use this formula when I have to calculate the perimeter for a rectangle. So if we look at an example, we have the following rectangle, and our breadth is 3 meters and our length is 11 meters. So our perimeter is equal to 2 times the length plus 2 times the breadth. So I have 2, and then in place of the length I've got 11 plus 2 times the breadth, which is 3, and this just gives me 22 plus 6, which gives me 28 meters. Then we have a triangle. Now notice the triangles have different if a triangle is an acute triangle, the height is inside. If it's an obtuse triangle, the height lies on the outside. Now the formula for triangle, that's just simply if we walk around the triangle, we'll have to add each of the sides. So the formula is simply A plus B plus C. Alright, and then if we want to calculate the perimeter for this triangle, now we have to add the 50 plus the 40 and then add AB, but we don't have AB, although it is a right angle triangle with 2 sides that's known. So first of all, we're just going to use Pythagoras. We're going to say that to find AB, we're going to say AB squared is equal to the long side, the hypotenuse side, so AC squared minus the other short side, BC squared. So that's the Pythagoras theorem of Pythagoras. And then we substitute in our values. It's 50 squared minus 40 squared. And therefore AB is equal to the square root of 50 squared minus 40 squared. So if I type that into the calculator, I have 50 squared minus 40 squared, and that gives me 30 meters. Alright, so now that we know this is 30, we can simply say that the perimeter is, in our case also, well, we can write it as AC plus BC plus AB. So this is going to be 50 plus 40 plus 30. So this gives me 90 plus 30 is 120. So this gives me 120 meters. Now we have a circle. So the perimeter of a circle is also called the circumference. So normally we don't for a circle say perimeter, we say calculate the circumference, and the circumference means going around the length that goes around the circle, if you should walk around it. Alright, and then the formula for a circle simply is the circumference is 2 pi r. We can also, since we see the radius, where the r is the radius is from the center of the circle to the circumference, and therefore the diameter, which goes straight through the circle, is twice the radius. So we can also use pi diameter times diameter, but I always, well, for simplicity's sake, I always use this unless I can't use this formula. I would use pi times diameter. So just to note that the diameter is 2 times the radius. Okay, so let's look at this example where we're given that the diameter is 14 centimeters. So I know my formula is the circumference is 2 pi r. And since the diameter is 14 centimeters, the radius, which would be half of that, which would be 7. So we have 2 pi times 7. And then we just type that into the calculator as is. We have 2 times, now your pi is for the Casio is down here, so you have to say shift pi times by 7, and this will give us 14 pi, but normally we have to give it in to 2 decimal places. So if I press SD, I get 43,98, and we're working with centimeters. Okay, so that was your basic formulas and some simple examples. Let's look at some notes. So the first thing we're going to look at is in calculations, all dimensions must be expressed in the same units. Now, what this basically means is sometimes you'll get a figure and they could give you different lengths but with different units. So you're going to have to convert all your lengths to the same units before you work out the perimeter. So also the perimeter is expressed in linear units such as millimeters, centimeters, meters, and kilometers, because it's a distance. So that's why it's a linear unit. And when you want to do your conversions, these are just a few of the conversions where we have 1 kilometer is 1,000 meters, 1 meter is 100 centimeters, and 1 centimeter is 10 millimeters. These are some of the common conversions that you might have to use. Then calculations involving circles usually include the irrational number pi, as we saw in the previous example. And then typical rational approximations for pi are 3,14159 or 3,14 and 22/7. But in grade 9, you can start using pi from the calculator because that's the most accurate to use. Unless the question states explicitly that you have to use 3,14 for your problem or 22/7, always use pi from the calculator. So use the pi button on your calculator for calculations, and do not round off until you get your final answer. So that was the notes. Let's look at a few examples. So for example 2, determine correct 2 decimal places the perimeter of the shape alongside. Right. So to start off, we want to go right around this shape. So we have this length, this, we don't have that. But normally what we do, if we have a complex figure like we do, we'd want to break it up into simpler parts. So if I construct a line over here, and I break this up into A, B, and C, then I have a semicircle, I have a rectangle, and I have a triangle. Now, what we know from a rectangle is that the opposite sides are equal in length. That means that if this is 4, this would be 4, which makes this a semicircle with a diameter of 4 centimeters. Whereas the radius then would be 2 centimeters. So we can calculate the circumference of a circle and half it. That would give us this length over here. Then we're left with this length, and how are we going to find that length? We're going to find this side using Pythagoras in this right angle triangle, and then we can equal it there. So let's get started with that. Let's start with B. To find this side, we can say that the side is, or we don't have any numbers now, so I'm just going to say that it is equal to, or let's say the side, rectangle, let's say the length over here, let's call that the length. So the length squared is equal to, see, this is the hypotenuse side, so the length squared is equal to 8 squared plus 6 squared. So the length is the square root of 8 squared plus 6 squared, and that would give us the square root of 8 squared plus 6 squared, so that gives us 10. Alright, so now we know that this is 10, so that makes this one also 10 centimeters. Now let's find this circumference here. We're going to say that the circumference is half. Okay, so we want to find the circumference but only half of it. So I'm going to say half of my formula for circumference, which is 2 pi r. Alright, because it's just half a circle. And then I can substitute in. So I have half times 2 pi, and my radius, and let's make this square brackets, my radius is 2, and then you can just put that just as it is in the calculator. So this will then be, or half, you can say 0.5 for half. I like to use 0.5, it's just simpler than putting in a fraction. Times 2 times pi times 2. So this is 2 pi, and then to 2 decimal places. Alright, also, remember what we said about rounding off until final answer. Let's not round this one off yet. Let's keep it as 2 pi because that's the most accurate. So if we know this circumference over here is 2 pi, now all we're left to do to find this final perimeter, we just go and walk around the shape. So let's start over at this point. If we walk along here, this is 10, then going down plus 4, plus 6, plus 8, plus 2 pi. Let's put that into the calculator and then round it off to 2 decimal places. So this gives us 10 plus 4 plus 6 plus 8 plus 2 times pi. Let's put that 2 times pi. And that gives us 34,28. And centimeters. Always remember your units, very important. Now for example 3, over here, correct to 1 decimal place the perimeter of the figure below, and it consists of an equilateral triangle placed on top of a semicircle. So this is important information because this tells us that if this is an equilateral triangle and this is 6 centimeters long, then this side will also be 6 and this side will also be 6. So to find the perimeter, we have this side now, but now we still need the semicircle's distance, the circumference of that. If this diameter is 6, then the radius will be 3, So in other words, we're going to say that our perimeter is equal to, so we go 6 plus this half of the circle. So half of the circle's formula is 2 pi r. Right, so we can just simplify that. So that's 12 plus half of 2 pi, and the radius is 3. And then let's put that into the calculator. So we have 12 plus, then let's put brackets over here and say 0.5. So this is the halves, 0.5 times, because see, all of these things are simply times together. This is one term. Right, so we've got times by 2 times by pi times by 3. And this gives us 21,42. And the units we're working with is centimeters. Right, so those were the examples. And this means you can now do exercise 15.1, only the calculators that include perimeter.